The Manhattan Project wasn't just the atomic bomb. It was a secret empire built at wartime speed, driven by fear, genius, and pressure. Here's the full story in about 7 minutes. It starts with nuclear fission. Split an atom and you release enormous energy. By the late 1930s, scientists realized this could become a weapon. And the fear has a name: Nazi Germany. If Germany builds an atomic bomb first, the war could end in a single flash. In 1939, physicist Leo Szilard convinces Albert Einstein to sign a warning letter to President Roosevelt. The message is simple: a bomb may be possible, and Germany might be pursuing it. The US reacts cautiously at first: committees, research, slow progress. Then Pearl Harbor happens. After that, the question changes overnight from "should we" to "how fast can we?" To move fast, the US needs both science and military logistics. General Leslie Groves takes control. He's an Army engineer who thinks in deadlines, budgets, and secrecy. He turns the project into a network of hidden sites and demands results. Groves then chooses J. Robert Oppenheimer to lead the science. Oppenheimer is brilliant and unusually good at uniting strong personalities. He's also politically risky. Groves picks him anyway because the project needs a leader who can translate theory into reality under extreme pressure. Oppenheimer selects Los Alamos in New Mexico, a remote mesa that becomes a secret city. Scientists arrive with families. Life looks almost normal, but everything is controlled: guards, censored mail, compartmentalized information. Because they're building a weapon that could erase a city. The biggest challenge isn't the idea of a bomb, it's the fuel. The project pursues two options: uranium-235 and plutonium. Uranium-235 exists naturally, but it's rare. Separating it from the more common uranium-238 is incredibly difficult. So the US builds Oak Ridge, Tennessee, massive enrichment facilities running day and night. Many workers don't know what they're producing. They're told to watch gauges, follow instructions, and never ask questions. Plutonium is even stranger. It has to be manufactured. For that, the US builds Hanford in Washington state, reactors and chemical plants designed to produce plutonium at industrial scale. It's a huge gamble, creating a new element to power a weapon no one has ever seen. At Los Alamos, they work on two bomb designs. The uranium approach seems straightforward: a gun-type bomb, where one piece of uranium is fired into another to form a supercritical mass. It's still complex, but the concept is simple. Plutonium looks promising, until the project hits a shock. Reactor-produced plutonium contains isotopes that release extra neutrons. In a gun-type design, that can trigger the chain reaction too early. The result could be a fizzle, not the intended blast, but a dangerous failure that spreads radioactive material. That means the easy plutonium design is basically dead. So they pivot to the hardest solution: implosion. Implosion means using explosives to compress a plutonium core inward from all sides at nearly the same instant. Symmetry is everything. If the timing is off, the core compresses unevenly and the bomb fails. Scientists and engineers scramble to solve this, designing explosive lenses, improving detonators, and measuring timing in microseconds. They're inventing new engineering while the clock is still ticking. By 1945, the project is ready for a full-scale test. The first detonation is planned in the New Mexico desert. The device is called Trinity. Storms and lightning threaten delays. Everyone understands what's at stake. If it works, the world changes forever. Trinity goes off. A blinding flash turns night into day. The shockwave hits seconds later. A mushroom cloud rises into the sky. The bomb works. The weapon is no longer theory. Now the story shifts from science to decisions. Germany has surrendered, so the original fear, Germany building the bomb first, is gone. But the war with Japan continues, and US leaders believe an invasion would cost enormous lives. They decide the bomb could force surrender quickly. Two weapons are prepared: Little Boy, a uranium gun-type bomb; Fat Man, a plutonium implosion bomb. The uranium weapon isn't fully tested. Uranium-235 is too scarce to waste. the decision is made anyway. August 6, 1945. Little boy is dropped on Hiroshima. In seconds, the blast and heat destroy large parts of the city and kill tens of thousands. Japan's leadership is stunned, but surrender doesn't come immediately. Days later, a second mission proceeds. Weather affects the plan, and the bomber diverts. Fat Man is dropped on Nagasaki. Another city is devastated. After this, Japan moves toward surrender. World War II ends. But the Manhattan Project doesn't end with victory. It begins the atomic age. Once the bomb exists, it can't be uninvented. The Soviet Union accelerates its own program. The world enters a Cold War defined by deterrence, fear, and the possibility of nuclear annihilation. That's the legacy. The Manhattan Project proved humans can build the unimaginable at maximum speed, then spend generations living with the consequences. If you want more stories like this, from ancient empires to modern breakthroughs, follow for more short history.